before going into the presentation, I wanted to ask you how many of you have been in this summit 4 years ago, in 2018? Raise your hands. Okay. Did you remember that I did a similar presentation like that? Do you recall? So first of all, just a few words about Gerrit Forge. Our headquarters are in Sunnyvale. And actually, that's the reason why also the summit is actually split in two parts. One part is here in Gothenburg, but at 4 o'clock, we would switch the live stream from Gothenburg to Sunnyvale. There will people continue in Sunnyvale. But we have been in the field for a lot more than 4 years. So we started contributing to Gerrit. I believe my first commit was in 2011. But I was already working on Git, JGit, and the integration of Git in the enterprise since at least 2009. There were some ideas also before that. So we are, of course, active contributors of the Gerrit Code Review project, but not just that. So we started in the last 2-3 years to contribute a lot to JGit. And actually, a news that will come out in a couple of weeks, we will be the one hosting the JGit code reviews as well. So because the Eclipse Foundation has decided to shut down Gerrit, so we offer to JGit and eGit and any other projects on the Eclipse Foundation, if they want to continue using Gerrit, they can use Gerrit Hub that is hosted by Gerrit Forge. And we are contributing a lot more to JGit. Then, of course, historically, I've always been a great fan of Jenkins, and I'm going to be a super duper great fan of Zool as well. And recently, we started also extending Gatling and using Spark for doing crunching on code reviews, on data. Nowadays, it's getting very popular, say, the idea of using machine learning, AI for development. But we started many years ago by saying, listen, your data is a gold mine of information. So your code could be information for other developers. So you should gather information, process your information, and serve it back to your development team. Back to 2019. So I was exactly here, and not a surprise I used the same backdrop because I liked it very much, the idea of having Sunnyvale and Gothenburg. So back in 2019, we were doing one event in two places, but at two different times. So we were doing in August in Gothenburg, where the weather was a lot better than this one, but today it's not that bad. And in November in Sunnyvale, where we're still doing beach volley in November in Sunnyvale. And we were just talking to everyone that multi-site is not anymore, let's say, a big implementation from Google that is proprietary from Google. But thanks to all the help from Google, we managed to make an open source version of multi-site. It was open to everyone. Since 2019, many companies started adopting multi-site. And we'll see what is multi-site. We'll do a little bit of recap. So first of all, let's do a little bit of recap of what is multi-site and what is in general multi-primary setups. So just a question, raise your hand, how many of you have got more than one primary Gerrit server in production? Raise your hand. I'm really shocked that some of you still have just one. What happens if that one goes down? People are not very happy in the company, right? Okay. So first of all, when you talk about Gerrit multi-primary, it means you've got more than one server. And the reason to have more than one is the same reason why your airplane doesn't have a single engine, right? Because if one breaks, you want to make sure that things keeps on going, right? And it's true that on the jet, let's say, of course, having just one engine that is failing is life-threatening. But nowadays, if you think about software is used everywhere. A fault in the software can be life-threatening as well. So we need to start thinking about, let's say, that software is not anymore something that, okay, may break, it's not a big deal. No, if software breaks, it's a big deal. It's going to maybe break the engine of a car, or maybe a self-driving car could go and crash into something else. So having more than one is always a good idea, right? So, and that we call multi-primary. Bear in mind, in Gerrit, historically, multi-primary has been there for at least 10 years. But it was just Google implementing it. And the code that Google wrote in the past for doing multi-primary was not open source. That's why we couldn't use it. And let's do one step forward. So multi-primary means you've got two primaries. But actually, if you have two Gerrit servers, they are completely independent. You are kind of multi-primary, but not so much because you cannot really leverage the fact to have two Gerrit servers, right? So then when you talk about multi-primary and you say, I use multi-primary in high availability, it means that it's not just you got more than one primary Gerrit server, but they share something. So it means they start sharing, for instance, the repositories. The repositories are exactly the same in all the primaries you've got. Using maybe a shared file system, NFS, whatever you want, you name it. Then another thing that you've got, of course, is that if one server goes down, the other one needs to take over immediately. So you need to start sharing sessions. For instance, you may use web session flat file or web session broker, whatever you want, but any kind of plugin in Gerrit that removes the session from, let's say, your local database and share with the others. And then, of course, you may have other entities in Gerrit that could be cached or not cached, like, shared or not shared, like caches and indexes. But when you start talking about multi-site, it's something more than just having more than one primary. It means that you just don't have only more than one primary, but you have more than one places in the globe or in your company where people can access Gerrit. To give you one example, imagine that I'm sure that Volvo has other development teams around the globe and your companies also have other development teams around the globe. It means that everyone will use their local Gerrit primary. They will not go to a load balancer that goes across a cluster, but it will go to their local, and they know whatever they do locally will be eventually replicated to the rest of the world. So the difference between high availability and multi-site is this one. In high availability, it means you really do balancing between them, and you use all the nodes at the same time. If one, let's say, goes down, the other one is there, taking over immediately, the data is there. Multi-site, it means you've got different Gerrit servers. They are completely independent, but you know that the data that you push to one server will be eventually replicated everywhere. And they are called multi-primary because it means all different sites can read and write data at the same time, okay? This was a simple recap, otherwise maybe you will not follow the rest of the slides. Okay, just to give you some little examples. So you see on the left side what is high availability. So we've got a shared entry point. Typically it's HA proxy or any load balancer you want. It could be, I don't know, Kubernetes, Ingress, whatever. And the shared data as well, because the data is all shared on the same file system. And then you can instantiate, imagine, I don't know, auto-scaling group, one primary, two primary, three primaries, put as many as you want. But you consider everything as a unique thing, right? And that can be only located into a single site. So it means that if you do, for instance, a HA cluster in the US, if you are in China, you need to wait. If you're in India, you need to wait. If you're in Europe, in the morning it's fast, in the evening, well, not so fast, right? Multi-site is different. It means that you got multiple primaries. As you can see, every stack is absolutely independent. So if there is network problem between the different primary sites, they keep on working exactly as before. But there is a cross communication between the two in terms of balancing, in terms of replication, and so on. That's a fundamental difference, okay? Okay, so this is a simple table that allows you to choose if you want to do single primary, high availability, or multi-site. And I put different aspects, right? How much is important for you the scalability? How much is important for you the performance? How much you need to be available? And do you really have the problem of data locality or not? So if your team is all co-located in Gothenburg, maybe you don't have that problem. So maybe you don't need multi-site. But if some of the people are in Gothenburg, other people are in the US and so on, maybe you need that. And then the latency that is very important. So because people keep on working on the code, then the lower is the latency, the faster is the throughput of your development teams. As you can see, multi-site is not the, let's say, silver bullet that solves all the problem, right? Because it's not very scalable. So you cannot really take multi-site and think, okay, now I can do workload balancing of all my load across China, US, Europe, and I don't know, a forest. You can't really do that, right? Because otherwise you will get some of the calls from your browser go in China, others they go to the US, others that goes to Europe. It's not really suitable for scalability. If you want scalability, HA. That allows you to scale as much as you want. But it's definitely very fast. So you got the same level of performance of a single primary on multi-site. Whilst if you go start doing HA, you know that NFS is not very fast, right? And so on. So the thing that you really obtain and get when you do multi-site is the maximum availability you can have. Because regardless of what happens on the single site or across the sites and so on, the people will continue to be able to work. And when the sites will come back, they will eventually replicate. Okay, so this was a slide from 2019, right? They were saying, we reached that goal. So we were, let's say, really struggling and really developing for many, many years. There were countless of discussions with Sean peers to try to understand how they did it in Google, because we wanted to make the open source version. And in 2019, finally managed. And we saw, yes, we've done it. Now we can do maybe doing something else. And then, whilst we were implementing multi-site in GitHub.io with many other clients, we saw that when you reach the top, you see that there are some highest mountains. You didn't see that before. How many times? I like hiking mountains, right? And when you are at the bottom of the mountain, you say, oh, that's the top. We'll get there, that you're coming there to the top, you're sweaty. They say, I made it. Oh my gosh, there is a bigger one that I need to go and high. And that's life, yeah? And that's the reason why we keep on working, we keep on doing stuff, right? And when we reached that peak, we saw that there were many more challenges that we wanted to tackle. I wouldn't say that now we sorted all of the problems of multi-site, but we are getting very close. As you can see, the flag, Gerrit Multi-Site 2023, is not very far from the top, right? That is Mount Everest, so hopefully there are no bigger mountains than that, but we'll see. Okay, so just to recap, how was it in 2018? So we had already the ability to have different HA cluster connected to multi-site. We were using the replication plugin, and the multi-site plugin was able to do replication of changes, indexes, caches, sessions, and everything. And we had already that type of connection of HA proxy that allowed us to be completely independent between sites. However, there were still some limitations between the type of traffic. So we could use the sum of the sites only for maybe read or analytics, or maybe some failover, but we were not able to do concurrent writes at the same time on all the sites in a super duper reliable way. So there was always, let's say, some logic that companies needed to put in place by saying, you can write to this project, but not to the other project, because, you know, there could be some replication delays. And the main problem was the replication plugin. So this is how it looks like in 2023. So first of all, as you can see, the stack has become bigger. So it means now you can do scaling how much as you want within a single site. And we swapped the replication plugin with the pull-replication plugin. And the main reason was reducing latency, okay? And then, of course, you still have chat proxy, but now you can do any read-write traffic to any location at the same time. Even if you go someone in the US or someone in China, they go and push the same commit on the same branch and push the same branch at the same time, the system will still be consistent. And the main reason is the introduction of the global RefDB. That is basically a place where the mutable state is going to be coordinated. It's exactly like it happens also when you have a single primary. Have you ever tried to have a single primary and do a test that is pushing the same commit to the same branch at the same time on a single primary? Have you done the test? If you didn't, so try to do that test. You would see that one of the two pushes will fail with a lock error, and the second will go through. And the one that fails with the lock error will retry it. It will say you're not up to date. You need to fetch first. Okay? So we basically replicated the same behavior with multi-site. It will happen exactly the same thing. So if you have someone in the US and someone in China will try to push exactly the same commit on the same mutable branch, what will happen is that one of the two will get a lock failure and the other will retry and they will see, oh, now I need to fetch first. So exactly the same experience from that point of view. And we're going to see then later on how we managed to make it so fast and so effective, even if there were different sites. And we replaced the point-to-point communication with a generic reliable broker, because point-to-point communication was not even scalable in terms of number of sites, right? When you start doing point-to-point, but you start increasing the number of sites, then you see that the complexity of the interaction between the points becomes a big mess, becomes a kind of interlaced series of strings, and then interactions that become so complex they become a bottleneck and an impediment. You lose track of them. With a reliable broker, things are completely different. So you push your events on reliable broker, and whoever site is online will get those events. If you're offline, it's not a problem. The broker will keep track of where you were left when you were online. And when you come back online, we'll say, hold on, before going back online, that's the amount of work you need to do, right? Because the other sides did all this work, okay? So I believe this was one of the missing pieces when other implementation of Git tried to do multi-site and they failed miserably. That basically they implemented multi-site, but they forgot to put a reliable broker. So what happened is that the two sides stopped communicating between each other for something like 15, 20 seconds. When they came back, they didn't have a backlog to catch up. They came back and they were misaligned. And they started accepting traffic and writes when they were misaligned. Do you know what type of problems they had after that? Split brain. Because of the lack of a reliable broker that was telling you, hold on, before accepting all these writes, that's the amount of work that you missed, that you need to implement. They started accepting write and ended up in a situation where they created two alternative realities of the same branches. You don't want to get into that situation. So that's why reliable broker is really, really important. For the people that don't know, actually, Gerrit had already a broker in the Gerrit primary for a very long time. It's called even bus. The problem was, is in memory, is not persistent, and is not reliable. So if you kill Gerrit, all your in-memory events are lost. Here, you kill Gerrit, you go kill -9 Gerrit. When it comes back, all the events are there and it will catch up. The lack of the persistent was also felt by the Gerrit trigger plugin. And that's why there was all the series of, let's say, kind of hacky situations with the event log that is stored into a database, then is sending to REST API, and then the Gerrit trigger plugin tries to understand where it is, calling the event log with the REST API. It was just a messy solution to an underlying problem that we didn't have a reliable broker. And now we do. So Gerrit has a specific component that is called events broker, where you can plug whatever implementation you want. And you will allow different primaries to talk to each other in a reliable way, in a way that is going to prevent also future split brains. So those are the two big components. The global RefDB that gave you the same level of concurrency locking that you had with single primary, and the reliable broker. Pull replication, I will just go quickly, but just to give you the services and the advantages. So first of all, pull replication has been integrated with the global RefDB as well. So it means it's able to understand which replication events are not useful anymore. Because when you catch up, right, a system was behind and then was catching up. Maybe some events in some refs, they don't exist anymore, and maybe they've been already up to date. So for you, there is no point in executing misreplication events that are not useful anymore. And also, there is the massive reduction of latencies, right? So when we were talking about the push replication, the typical push replication latency is from a minimum of seconds. The minimum unit for Gerrit is 1 second. So you cannot have a push replication event that is faster than 1 second, because Gerrit will delay at least by 1 second. If you put 0, bad idea, because you got a push replication that is going to conflict with the in-flight pushes that Gerrit is executing. So in push replication was from a minimum of 1 second to typically tens of minutes. I heard people also waiting hours for replication. And that was not good enough for having active-active, right, in all different sites. You cannot say, oh, you cannot push to this branch for an hour, waiting for replication from China to complete. Is there a lunch break? Yeah, go ahead, have a lunch break. And when you finish your lunch break, you know they pushed another commit, another hour. Yeah, it's not possible. So we needed to speed things up. And the reason why we implemented pull replication is because Google didn't use replication plugin. So, and when we discovered, and it was many years ago we discovered, and we say, why on earth we use push replication plugins if you guys that design Gerrit don't use push replication plugin? And they told us two main reasons. First, because push replication doesn't do negotiation. So when you replicate data, it's going to be very not optimized, and the repo on the other side is going to look awful because of the lack of negotiation. Second, it's incredibly slow, so it's never going to work. I say, okay, what do you use? And they describe what they do. So we listened to all the suggestions that they gave us, and we implemented from scratch a new replication plugin that was called pull replication. And we also implemented a specific intelligent API that is called apply objects. And there is going to be a talk about pull replication. We'll tell you exactly all the secrets of these apply objects. But with this specific combination of the git fetch and the apply objects, we managed to reach P99 1 second. P99. It means that if you go on average it's between 20 and 50 milliseconds replication, and P95 100 milliseconds. So it means that the moment that someone is pushing something in China, then within 1 second, you got it in the US already. So I'm sorry, long lunch break, not possible anymore. Maximum lunch break, 1 second, and then you have no excuses anymore. Then of course, if you go to just the fetch, so when you use the apply object, you get to that level. When you get the fetch protocol is still quite slow in JGit. We did a lot of implementations with the Git protocol v2, but we managed to get to these figures, 2 minutes to 10 minutes. And the last one is a lot easier setup. When you were configuring push replication, the problem is that you needed to configure a Git daemon, right? That was completely standalone. With pull replication, you don't need a Git daemon anymore. So I believe Alvaro implemented a new functionality in Gerrit that is called bearer token. That is a way to allow certain operation to happen without being authenticated with Gerrit, but not exposing any accounts in Gerrit at all, right? Something very similar that you can do also with the Prometheus when you want to scrape metrics. And in that way, we were allowing the pull replication to do all the things that Gerrit needs for creating, removing projects, creating branches, configuring projects, and so on, and accounts. And you don't need anymore to do the Git daemon completely isolated. There are a lot of advantages. First of all, security, right? Because always creating a different Git daemon that goes behind Gerrit back and is not authenticated was always a big hurdle, right, in terms of security. I'm not going too much details because there's going to be two different talks that you can follow. So first of all, there's going to be this afternoon from Sunnyvale, Marcin Czech and Christoforos Miliotis, that will show the improvements they implemented on pull replication. In particular, they implemented the transactionality of multiple refs replicated all or nothing on pull replication, which is really good. This is possible from Gerrit 3.9, that is not out yet. And the replay, the talk that Marcin Alvaro did last year in the Gerrit User Summit in London. So, this is very important. So when you talk about multi-site, okay, you need to understand what we want to achieve in terms of consistency. So there is a theorem on the distributed systems that between consistency, availability, and partition tolerance, you cannot have all the three together. So if you look for any solution that will achieve all of them, and someone is telling you that it exists, it's impossible. It's been demonstrated it's impossible. But you can choose between CA, consistent and available, AP, available and partition tolerance, or partition tolerant and consistent, right? So we have decided to make the multi-site an AP system. So you don't get the global consistency. It means that if you take a snapshot, and if you have multi-site in production, try to do that. If you take a snapshot of all the repos, of all the refs, on all exactly the same milliseconds in all the sites, you will see they are never the same. They are always different. And the reason is very simple. You need to think about multi-site like, let's say, the Mississippi River, where there is a lot of data and multiple bridges. It's still the same water. The water will flow from one end to the other, will eventually get there, but the different sites are like different bridges on the river. If they take a picture of the river at the same time, maybe put some paper boats, they will never see the same thing. But eventually, all the water will go through all of them. And that's the reason why we implemented this. So I will go quickly because there will be more presentation about the global RefDB here, but the role of global RefDB is being aware that there are these differences in latency and making sure that if two people are pushing at the same time, exactly on the same ref, exactly in the same milliseconds, one of the two will win and will understand that is outdated. And they will get a notification and a log failure. So this is what the global RefDB is. So is going to have a subset of the local RefDB. The RefDB is the key value store that associates the refs of your repo with the SHA ones. Will not get all of them, we'll just get the mutable ones because you don't have a problem with immutable state. Immutable state is consistent by definition, okay? But the mutable state is the problem. The fact that I say master is, sorry, primary or main branch is 1. And you say, no, main branch is 2. Who is right? But if I state something that is immutable, that is, my name is Luca, and his name is Diego, those are different, and we are immutable, okay? So the mutable refs that we track on the global RefDB are ref heads, ref tags, ref changes meta, and ref multi-site version. Ref multi-site version is an extra ref that is going to be given to the different repos to have a heuristic of how up-to-date you are compared to the others. And we made in a way that could have been completely pluggable in different organizations because the global RefDB and the broker is not something that your organization doesn't have already. I'm sure that your organization have a key value store. And sure that your organization uses some cloud environment or maybe uses already a broker. So because we wanted to make a multi-site implementation for the open source for everyone, not just for us, we didn't want you to make our choices. So for instance, on GitHub.io, we also changed our minds. So we started, for instance, with Kafka on GitHub.io. Now we're going on AWS Kinesis. Maybe tomorrow we'll go to something else. And that's absolutely fine. So this is completely pluggable. And you can plug different things. This is just an example. The reason why I said we invest more and more in JGit, because we needed to go more and more in JGit to implement multi-site. You cannot go stay just at Gerrit level if you want to implement multi-site. You need to go very, very deep and close to JGit. So if you have the ref database in JGit, for instance, in this case, site 1, that is pointed to AAA. But in site B, you're pointed to BDB. Who is the latest? Nobody knows, right? So the global RefDB is the one that is telling you who is the latest, okay? So the first API that the global RefDB is giving you is, are you up to date or not? Bear in mind that that is not absolute because the moment that you get the answer is already outdated, right? So that is not enough. The second API that we needed to implement is the compare and set or compare and swap, the CAS operation, because you typically say, am I up to date? Yes. Then you get the value and you say, okay, assuming that the value has not changed, and look at the site 1, assuming that the value AAA has not changed, can you please update it to AA1? Okay? And maybe site 2 will say, assuming that the value AAA has not changed, can you please update it to AA2? Okay? In that case, one of the two will succeed and the other will fail. In this slide, there is a mistake. Site 2 was with the K1 to AAA, not the BDB, right? Because otherwise, we'll have failed the first check. Is up to date. So as I mentioned, we wanted to make it very, very open. And I have to say that we are not the ones that implemented all of them. Actually, the idea of doing a global RefDB in the open source was from Sean. When Sean implemented multi-site in Google, he said, what about if you're not Google? Maybe you need to add something else. And Sean started creating the Zookeeper, repository for a global RefDB. But then, of course, Sean was very busy and then gave to Dave Borowitz the task to go and implement the Zookeeper. But then the problem was just that component was done, but not everything else. Then we took over and we say, Dave, do you mind if we just continue your little project? He said, no problem, do whatever you want. And we made it, let's say, more production ready. Then we implemented in 2021 the DynamoDB, because if you install, let's say, Gerrit on AWS, of course, Kafka is a lot more expensive than DynamoDB. So maybe saving some money is always good, yeah? And Matthias Son actually implemented this year also Google Cloud Spanner. So if you're, let's say, deploying your stuff on Google Cloud and using Kubernetes, then you can also use Spanner. So say a big thank you to Matthias that possibly is watching us as well. Yeah, maybe a remote applause for Matthias. If you want to know more about Global RefDB, there's going to be a session this afternoon, so it's going to be the morning for Sunnyvale, and it's going to be Daniela Sassoli from the US that is going to give us more details. Last but not least, the event broker. So event broker is the one that is going to broadcast everything. And when I say all the events, it's not just stream events. Gerrit has many more events than just stream events. But first, of course, the stream events. So if you're still using SSH stream events, put in your diary, get rid of SSH stream events because they are unreliable. SSH protocol is not scalable, doesn't support clustering, is stateful, many, many reasons, right? And try to move to, let's say, more pub/sub stream events. But then Gerrit has also cache eviction events. Those are very important, right? Because if you evict cache on one side, even if you do replication on the other side, you want to make sure that the cache is evicted everywhere. Or reindexing a very expensive operation. You don't want to do reindexing all the time. You want to make sure that you reindex it just once and when it's needed. And last but not least, user sessions. But user session can be broadcasted across sites or not, depending on your company policies, right? So some of the companies say, yes, I want to broadcast sessions. Other companies say, absolutely not. I don't want to broadcast any sessions, right? If you update an entity or if you read an entity, basically the pub/sub system will have a publish on one side. Whoever is updating an entity and everyone else will consume that key. And same thing, you should do the same for Jenkins. Bear in mind that the multi-site allows you backward compatibility if you're still consuming SSH stream events. So if you're still a Gerrit Trigger plugin, you connect via SSH to one of the sites, you will receive the events even if the push happened on a different site, which is really, really good because it allows you to, let's say, for instance, if you're using Zool with still SSH stream events, it will still work. Those are the implementations. So first of all, another applause to David, that I believe is here, right? There we go. For the RabbitMQ, because it's not done yet, but thank you for start the project on porting RabbitMQ to the events broker. But many other implementations are already there. So Kafka, I did it back in 2016. I can't believe it, I'm so old. Then Marcin did the Google pub/sub, and Ponch did the Kinesis a couple of years ago. And again, because everything is open source, the interface is absolutely declared. So it's not absolutely a problem to go and put your implementation. Imagine your company has a custom pub/sub system. That could be done as well. First of all, I've got here two different sites. One is on Firefox, is localhost 18081. And there is as you see, that's the port, and there is another one on Safari. And the two sites are running here side by side. Let me synchronize. So if you see, one is called instance 1 and the other is called instance 2. If you want to have an example of this demo environment, is actually in the multi-site code. So if you clone the multi-site plugin, you will see a script. You run the script, creates all the environment with a snap of a finger. So it creates Kafka, Zookeeper, all the instances, configuration, pull replication, all configured, because there were many questions on the mailing list. How do I set up multi-site? Can you give me some examples? Say, check the code. The code is the example. It contains a fully running environment that you can go run locally and have an example on how it works. And we did it first of all for us because we didn't want to start implementing multi-site just with some kind of unit testing and that's it, let's hope for the best. We started straight away from the first hackathon with an end-to-end environment. That was our first commit. Shall we create an end-to-end environment that we developers can use? And that is going to be the same example for you. That is the one that I'm going to show you now. On the logs, error log, they are both running. I restarted a few times this morning. So, and I wanted to show you as well on the logs that every component that you saw there is represented by a specific log stream. So you've got the, in this case, I'm using also the web sessions broker, so I'm basically creating sessions whenever someone is logging in. The two different sites, they are going to consume the sessions and the updates. And I have the pull-replication log, this one, so whenever someone is doing any operation on one and the other, they're going to execute the API. You can see that most of the times the apply object is done. So if we want to see that in real life, so imagine here just to tail -f the pull-replication log. Let me clear this one, and just going to make a change here. I give a +2, and you will see the replication happens. As you can see, I wasn't quick enough in switching, but really happened in fractions of seconds. In production, it could get up to 1 second. Immediately, when someone is doing something here, on the other side, if you go to the same change, is immediately there. Another thing that we implemented was really important. Because pull replication was so fast, we say, why don't we make it synchronous instead of asynchronous? And the reason was very simple. Imagine you've got someone in the US that is over the phone with someone in China. And they say, okay, I gave you +2, can you check? When the guy in the US is saying, I gave you +2, can you check? Is when he saw the feedback from the GUI that the +2 was applied. If you do asynchronously, the other guy from China will say, no, I don't see it. So, can you refresh the page? Oh, now I see it. That's a bad user experience. We said, why don't we delay the user just for maybe 50 or 100 milliseconds? No, nobody's going to notice that. And when you get the feedback from your site, you know that all the other sites are already replicated. So it gives you really the impression that things are updated in real time, because they are actually updated in near real time. Then, of course, it's a flexible configuration. You can say some of the things are going to be synchronous, other they keep on being asynchronous, right? Because if you have a push of 1 gigabyte, you don't want to do replication synchronously. But if you have a replication that happens in 10 milliseconds, why not? Last but not least, the shared FTP. So this log is basically telling you whenever a specific site did an update or did a lock on the shared FTP, okay? And that's very important, because for understanding when things goes wrong, you need to understand exactly if, let's say, the data was updated on this side, on the other side, okay? So here, replication works exactly like push replication. So if you want the site to wait for the replication to be on holdouts, you can do that if you want, because we'll still have the ref replicated. But if you really want to say, I want to just wait for replication to be completed synchronously, you can configure that as well. Just be sure not to exaggerate too much with applying the synchronous replication. So what's the advantage of synchronous replication compared to the CI? Because also the ref updated will happen after all replications have completed. It means that if you are multi-site and you do synchronous replication, when the CI gets the ref updated, you know that whatever the site you are, the data is there. Okay, so you have the choice. Still doing with ref replicated as you were doing with the primary replica, typically for years, or you can use synchronous replication. And there is going to be a presentation later today talking about pluggable health checks, because at the moment the site will still be considered healthy even if it is behind. And then you're right, so if you're fetching from a site that is behind, then of course you're not going to have a great user experience, right? Because you're fetching data and maybe the data is very much behind. But with the ability of allowing plugins to contribute to other plugins, so Tony implemented an extension to the health check plugin to get a feedback from multi-site, in a way that if a site starts becoming too behind, It can be also, let's say, taken offline. So when you fetch from a site that is more up to date than the one that you wanted to fetch from. So you could decide in that case. Okay, so there are some challenges here, okay? Not because of the multi-site components, but because of the Git replication. So Git replication today does not allow pub/sub. So you cannot do a Git fetch over pub/sub. You cannot do that. So in order to fetch, you need to have an endpoint. And because you need to have an endpoint, the problem is if you add one more site, then you need to configure this one more site to get and fetch from everyone. And the more sites you add, the things are getting more complicated. And also the other things, everyone needs to know that you exist because they need to talk to you. So I know for sure that Google was working still a couple of years ago on a CDN protocol for Git to pull from a kind of community of sites. Because at the end of the day, if you're multi-site, you don't have to pull from one. You can ask everyone, can you guys give me whatever is latest? You can get from everyone, even concurrently, so you can improve performance. So there was a proposal to extend the Git protocol to support CDNs and support the ability to run concurrently and fetch in different paths from different sites at the same time. When that is possible and when that has been implemented, then also, let's say, it will become easier to add more sites from a Git perspective. But from a multi-site perspective itself, it's not very difficult, because the only thing you need to do is basically just to create a new site. Every site has a specific ID associated that is called instance ID. And then, of course, you need to just to configure. We use automatically instance ID for fetching from the pub/sub in a way that one site doesn't steal the events from the others. But the tricky part is the replication, because we'll need a little bit of a fiddling part everywhere. Absolutely yes, and they should be used together. Because if you are in a site where there is a lot of people, maybe thousands of engineers, then maybe you want to be scalable there as well. For sure, improving the replication and the integration of replication together with the events broker. So there was some proposal from Marcin to do the apply object via pub/sub as well. For instance, in that case, you can get directly your commits via broker. We haven't done it yet, but it could be a very cool idea. And many others could be also to give the ability of using, say, global FTP that is not so global. Because you may argue, oh, this is all distributed. What about if the global FTP fails? Then you're stuck again. So, of course, in the cloud, there are a lot of implementation of global FTP. They're already multi-site by themselves, so you don't have the problem. But there are still limitations, because even AWS doesn't give you a DynamoDB that is completely multi-region. Yeah? So in that case, possibly the ability to have different global FTPs and still be able to manage them could be an extension. But again, the next extension comes from you guys. You use it in prod and say, guys, this all works fine, but it will be nice if we could do that. Okay? And one thing that is very important, I wanted to mention the name of the companies and the people, because multi-site is not Gerrit Forge initiative, it's the Gerrit community initiative. Started from Sean, then we continued, SAP continued, Access continues it, and we should work all together to make multi-site better. And thank you very much for your attention. Yeah.